Greetings, everyone. Good afternoon.
Good afternoon.
Going to share screen with everyone. So hopefully you can see this. Is that everyone can, hopefully?
Yes.
Okay, perfect. So our agenda today is essentially to finish up with Python. And we're going to be looking at Python modules, exception handling, and classes. And basically I have a in-class exercise dealing with classes that I'm going to have you all do just to give you some practice in Python. You're going to be creating a doubly linked list, and I want you to get some practice with how you can do that. Just like with Java, it can be a little disconcerting not having pointers, but yet you can still create linked structures. So I want to show you how to do that in Python, or have you do that. I figured out I can hold office hours. I will give credit to my wife. She figured out that I can hold office hours immediately after class in Min-Gal, therefore I can start them earlier. So roughly speaking, I'm going to start office hours today around 2:35, and they'll go to 3:45. So today's our last day on Python. A couple quick things. One, I wanted you all to be sure that you really do on this second problem, you're counting the number of times each word occurs, in a file. And I wanted to emphasize you have to use a dictionary to keep track of the word frequencies. You're not allowed to use a list to keep track of the word frequencies. So this is a little bit like the exam problem where you, instead of counting up candidate vote tallies, you're now counting up word frequencies, but it's the same idea. You're counting up the number of times each word occurs in the file. So I want you to use a dictionary to do that. And then when you're done, you're not going to have them in ascending order on the frequency. So you're going to have to dump the dictionary to a list to sort it by word frequencies. And that's where the iter items or the items comes in. So you can then dump the dictionary using either one of those, and it will give you tuples that are key value pairs. And I showed you how you can sort a list of tuples. So you'll then sort the list of tuples, and you are being asked to sort primary key as frequency, secondary key, if there's a tie, is on alphabetical order, uppercase being significant. Okay, so are there questions about that one? Because in the past, I've seen too many solutions that just do the counting using lists, and I want you to get...
Yeah, I've got a question about that, sir.
Mm-hmm.
Are you okay with using subclasses of dictionaries? For example, I used a counter, which is from the default dict class, and it really is just a dictionary that specifies the type of the value, and it's meant for exactly this.
That's fine, yeah. I have no problem with that. Mm-hmm.
Thank you.
Yep, I just want, that's an order one solution. I'm good with that. I just don't want you using a linear search essentially, which is too easy to do. And then 3 is just basically giving you a lot of practice using lists, dictionaries, and sorting. So putting the moving parts together. And actually, I saw someone suggesting a competition to see who could do the Python program with the fewest lines. So I probably will actually, it's a little hard because if you actually are good about commenting, it means that your program will probably be longer, but I will be interested to see who can actually produce the shortest golf program. So I took, I think.
I've got a question about problem 2.
Yep, go.
So you said you wanted us to dump it into a list.
Mhm.
Could we have simply just sorted the dictionary and then used the list returned by sorted?
If you can sort the dictionary,
You can sort a dictionary
okay,
based on the value with a lambda function, yeah.
okay, yeah, that's fine. Yep,
Okay.
yep, no problems. I'll have to look into that one because I actually had not been aware of that. Yeah, if you can sort the dictionary directly, I'm okay with that. Okay. So at any rate, someone did suggest it would be interesting to see who's able to produce a file with the fewest number of lines. Mine, I think, the very bottom, I said mine was, my Python implementation took about 100 lines, but there were some comments in it. So anyhow, I probably will ask the TAs to tell me what is the solution with the least number of lines in it. Okay, other questions about the homework assignment? Okay, so I'm going to be going fairly quickly today until I get to classes, and then I'll slow up a little bit. And the reason I'll be going somewhat quickly is that the module mechanism and the exception handling are essentially based off Java. So if you know how Java does it, you essentially know how Python does it. So with modules, the Python way of doing things is that functions go into, so you can have a file called foo.py, and it may have some functions in it, like cosine, say, tangent, sine. So you can just say import, and you don't give the name, you don't say .py because that is assumed, and that will import the package into the namespace, but it will not import these functions into the namespace. So if you say import foo, you still are going to have to say foo.cos if you want to access the cosine function. If you want to import these three functions specifically, then you would say from foo import cos, tan, and sine. And now you could directly access these functions. So you could just call them, for example, as cosine now, because those three functions have been put into the current namespace. If you want to put everything from foo, you can say from foo import star, and then everything from foo gets imported into your namespace. And when Python imports a file like foo.py, it creates a PYC file standing for a compiled Python file. It's a bytecode. So this is a file of bytecodes. And I told you last time, but I'll repeat, that just like Java, Python has an interpreter that interprets these bytecodes, but unlike Python, does not try to compile them. into like using just-in-time compilation or a hotspot compiler. So all that foo.pyc does is it speeds up initial loads. It speeds up subsequent loads, but nothing further. It won't speed up execution because it's still interpreting the bytecodes. It just won't have to convert the source code to bytecodes a second time. And if you want to create packages like you did in Java, it's the same idea. You have a directory, and typically the directory is the same. The name of the directory is equal to the package name. So, and you can have sub packages if you want. So that would be subdirectories. Every package directory is supposed to have a underscore underscore, 2 underscores init underscore underscore dot py file that indicates its mere presence, even if it's empty, indicates that this should be a directory which is a package. So even if empty, signifies to Python that this directory represents a package. Now, I did some nosing around and found some conflicting information. So I've seen sources that say that since Python 3.3, you don't need the underscore init.py file anymore. I've seen others that say, no, you still do, including the Python tutorial that suggests you still need it. So I think the safe thing to do is just assume there should be an underscore init.py file if the directory is a package. Now, Python has also introduced something called namespace packages, and that doesn't seem to be their yet mainline way of doing packages, so we're not going to discuss it in this class. So instead, we are just going to use this version of packages. And if you want, with the import statement, you might think that, let's say I have a directory. So let's say that I have a graphics directory. So it has a init.py file. And then it has a graphics directory, which is a subdirectory. And it has an init.py file. It also has rect.py and circle.py. And then I have an events directory. And it has an init.py and a mouse.py, a keyboard.py. And now let's say in some program, I say from silhouette dot events import star. You probably think that it will automatically import mouse.py and keyboard.py into your namespace. You would be wrong. So in order for this import star to actually do that, in the init.py file, you would have to have a list defined called __all. And you would actually name the files that should be imported with the star. And notice there's no .py here, just the prefix names. So now after I've defined this all statement in the init.py, then when I say from silhouette.events import star, now these two files will get imported as I would expect. Okay. And so any questions about that? Pretty similar to Java, except that this init.py file needs to be present. And normally you have an all list defined in it that lists the files in the package so that an import star statement can import all of them.
So __all__ is a list that's defined in init.py?
You have to do it. It's not.
Right, but
Yeah.
it is in init.py.
Yeah, that's right,
Okay.
exactly. So it's basically init.py is a file that executes when you import a package. So it does any kind of initialization statements that are required for that package. So before anything in the package gets loaded, actually what gets loaded is that init.py file. And so if you have that all equals in that init.py file, it will execute and set up the list. Yes. Other questions about that? Okay, so then just like, remember Java had its class path flag, and that allowed it to find where the different packages were located. Python has a sys, so that was Java. Python uses the sys.pathlist to find modules. So you just add them to the list. Typically, you just append directories to this list. So if I just do Python, and import sys, you see that by default, there's a whole ton of directories that are already on this path. Normally, if you want to add your own ones, I'd say sys.path.append, say users BVZ, silhouette, and actually, I don't believe I have to add silhouette because just like in Java, I believe you only add it up to the level of the parent directory. Okay, so sys.path is what Python searches for modules. So you wouldn't say, for example, I wouldn't say import users BVZ silhouette. Instead, I would just say import silhouette. Okay, and it should be able to find it by going to this directory. Okay. So that does it for modules. So moving on to exception handling, it is, again, very similar to Python, I'm sorry, Java. The difference is, so it uses a try statement, but you'll notice instead of catch, it uses except. And the it names the exceptions using as keyword. And instead of throwing, you use raise. So a few differences, I guess the differences being, let's emphasize those differences. So Python exception handling. And differences from Java. So you catch exceptions using except rather than catch. You throw exceptions using raise rather than throw. And there is a else clause that executes before finally if try successfully completes. So it's a little bit like the else on a loop in Python, where the else executes if the loop completes without being broken out of. And generally, the idea is with the else clause, so anything that can cause an exception goes in the try. And code that cannot cause an exception goes in the else. Okay, so those are the big differences between Java's try-catch mechanism and Python's try-catch mechanism. Otherwise, everything is the same. Everything executes in the same order as with the finally clause. You can re-raise exceptions at the end of an except statement. If you want, notice here that an except with no exception is an unconditional catch. In Java, you would probably catch using exception, but in Python, you just would say except, and that will be an unconditional catch. Just like in Java, it goes from most specific to most general. So in ordering your exception statements, if you have something like, let's say that you have a list, or let's say you have an IO exception. Let's say that a file permissions exception is a subclass of IO exception. Then when you order your statements, you want this one to go first, this one to go second, because this one is more specific. If you put this one first, then it will catch any file permission exception, and this catch statement would never be executed. So it's just like Java in that you need to order them from most specific goes first. And most general goes last. Okay, and Java has its own exception. So TTTD. So if you raise, this is how you raise one. So just, it looks more like C++. There's no new here. So you just give the name of the exception and arguments to the constructor when you raise. And exception is the predefined Python class, just like in Java, that's the class that you extend. Pass is just saying the class is empty. It's a placeholder to say it's an empty class, nothing in it. In Java, obviously, we'd use an empty set of braces, but you can't do that in Python because of its indenting structure. So they had to have an actual command saying nothing goes in the class, it's empty. Then when you notice I created a class, I didn't create a constructor, and yet when I raise name error, I'm passing 2 arguments. So those will be passed in as a list in a variable called args. That only works if name error is a subclass of exception. Okay, if it's not a subclass of exception, then Python will give you an error message saying there's no 2 argument constructor, what's going on. But notice there's no constructor here. All Python does when you give a bunch of arguments, when you raise the exception, it packages it into a list called args, and then you can iterate through that list. Okay, and of course, if you want, you could define your own constructor, which we haven't talked about yet. So init is the constructor in Java. We will see that. So that's my common bug here. Don't forget to make your exception subclass exception. Okay, so that's what I meant. Here I did not make it subclass exception. I raised a name error and I get the error message, this constructor takes no arguments, because in fact, it doesn't. Okay, right? There's no constructor defined. So you have to make sure that you make it subclass exception. Okay, that's your quick and dirty intro to exception handling. Okay, there's a couple questions on the quiz about it. I think it's pretty straightforward. But if you have questions, don't hesitate to ask. Okay. In that case, we'll move on to classes, which are the most interesting thing because they are, in fact, quite different than Java. So Python and most scripting languages use a prototype instance model rather than a class instance model. So what does that mean? So what it means is that I'm getting some background noise. That's why I'm just going to mute all for a moment. Now I have to get rid of it. Hang on here. I'd love to be able, why can't I get rid of this? Oh, there we go. Okay. Okay, so class instance means that a class is not an object. So in class instance, class is a blueprint. But not a runtime object. And in fact, it is an immutable blueprint. So it is used as a blueprint for stamping out instances of a class. And every class will have exactly the same set of instance variables, the same set of methods. Okay? There's no way that you can delete an instance variable or add an additional instance variable to an instance or change the meaning of a method in an instance. It's immutable. With a prototype instance model, the class is actually a prototype. It's a mutable runtime object. So not only is it used to stamp out instances of objects, but it's mutable. You can add instance variables at runtime. You can delete instance variables. And methods are actually just instance variables. So that means by extension, you can add or delete methods or change their behavior on a dynamic way. And it will be propagated potentially to all instances. Okay, so the same thing, you can add, delete, or modify methods. Okay, so that's very flexible because it allows you to rapidly change the characteristics of an entire class of objects. So let's say that I have a prototype for a rectangle, some kind of like a labeled box. And it has an instance variable color. Okay, and maybe it's blue. But I may want to be able to demo different colors of the labeled box for a user. So what I can do is create many instances of this labeled box, display them in the graphical interface, and then by simply changing the color from, say, blue to black, I can change the colors of all of the sub-objects. Now I know I could do that with a class variable in C++ and Java as well. But let's say I wanted to add a new component to the label box. Maybe I want another text label. I want two labels. I could actually add dynamically a second label and then change the draw method to draw two labels. And I could do that without reloading the application. And that is not something I could do with Java or C++. So Python and scripting languages are set up to make rapid prototyping very easy. So you can quickly change things without shutting down the application and rebooting it. Okay, so let's just kind of walk through some of the syntax for Python. So it does use the keyword class to introduce a class. And then, so here's an example, class point. These would be considered class variables that are inherited by all instances. And then here is a method. And you'll notice that the method, the first argument is named self. Unlike C++ and Java, you do not have an implicit this pointer in Python. Instead, the pointer is passed to every method, but you must explicitly declare that pointer as the first argument. Okay? If you don't, it will still be the first argument, and you will be in a world of hurt because let's say that I forgot self and just had def add point P1. Well, P1 would actually be a pointer to this object. It would not be saying that I had a one argument method. It would be saying I have a 0 argument method with the quote, this pointer being named P1. So what I'm saying is don't fall into this trap of, don't fall into the trap of forgetting to declare that. If I just declared the function that way, P1 would actually be a self pointer. So it's always there. You just got to make sure you declare it explicitly. And it doesn't have to be named self, but by convention, everyone names it self. And if you want to refer to an instance variable inside the method, you must prefix it with self. Because if you don't, so if I say in here, if I say in this method, if I say x equals p1.x, this will not have the effect that you think it has. It will not assign to this x right here. Instead, it will create a local variable. That disappears when the method exits. So in fact, if you want to refer to an instance variable, you must refer to it using self and then the name of the instance variable. So this would have the effect that you want. By saying self.x equals p1.x, it would assign to that x. So that's a big gotcha in Python, is forgetting to put the self in front of an instance variable. Because if you don't, Python goes ahead and creates a local variable. Okay, so it might help. Remember I said that all methods use a hash table for their symbol table. So it is every function and every method and every class has this underscore underscore dict for dictionary underscore underscore defined. So point in this case, in its underscore underscore dict, x and y are defined. And now when you say new point equals, in add point, it gets new point. And if I were to say x equals, then x would get defined in this dictionary. So that's your issue is it always goes to the innermost dictionary, associate it with the function. So first it would look here for it. Okay, and also self, I forget to say self and P1 are also in this dictionary. So dictionaries are the way that Python tracks all variables in a function, a method, and a class or object. Okay, so like I said, you can add new values. So if I have, for example, class point, I can say point.x equals 10. Whoops. Should have been able to say point.x equals 10. Huh. Class foo. Ah, that's what happened. I didn't finish it off. Okay. Here I had not finished it off. Here I finished the class definition. Now I can say foo.x and it prints out. I create x equals foo, and the way I do that, class name x.x 10. Okay, I can override it, so I can say x.x equals 50. Foo.x is still 10. Delete x.x. So I can delete it. X.x is 10, because now it gets it from the parent. So when the way inheritance works is we chase the dictionary. So we first chase the dictionary for x, and it no longer had the attribute x in it. So then it went to the parent, which was foo, and it found x in the parent. So just because you delete an instance variable out of a instance object, if that instance variable is defined in the parent, it will now just inherit from the parent.
So this might be a stupid question.
Don't worry, this is different, so go ahead.
But what's to stop you from trying to access something that doesn't exist that you think exists, and then you simply added the thing you thought existed?
Nothing. That's the problem with scripting language.
This is terrible. I'm sorry, man. This is cursed.
Okay, so that is the it's a religious thing, and clearly a lot of people feel the same way you do. They just think this is an abomination. It's an invitation to, you get no warning message that you've done something wrong, and then your program just doesn't work. So
is there no way to protect a class that will keep you from doing that? So
no, I haven't yet even told you that everything's public. If you can't protect your variables very easily in Python either. So it's like I say, there's a lot about scripting languages that cause people to get up in arms. And one is the fact that you don't have to declare anything, that you can just use variables. And there's essentially no way to impose strict checking on them is a problem. I think in Perl you can. I think in Perl you might be able to force variables to at least be declared, but I don't think that's the case in Python. Okay, so as you can see, delete allows you to delete dynamically a instance variable. So you can give, I could say def print value x, actually I'll say self print self.x. I can now assign that. So I'll assign that to foo.print value equals print value. Now I can, in X, I can simply say X dot print value. It prints 10. Now, watch this. Can I do that for foo? No. Type error, unbound method print value must be called with foo instance as argument. Got nothing instead. What happened? What happened is print value is considered a method in every instance of foo, but is considered only a mere function in foo. So in order to get it to work, what? Foo.print value. That should have worked. Unbound method print. Okay, X.print value. Okay, well, there you have it. So I had to actually pass in an instance of X when I called it at the level of foo, because in foo, it's considered a function. So unbound method, let's see, X.print value. Bound method. See, there's a difference. So in foo, it's just effectively an unbound method, and if I want to invoke it from foo, I need to explicitly pass in an instance object. But if I have an instance object, I can simply call it as a method. So that can cause a little bit of confusion. Okay. So classes are objects, dynamic. Okay, so if you want to try to declare something as private, you can pull this stunt, but this is pretty weak. So there's kind of a convention that if you want something to be private, you put a underscore before it or a double underscore. But someone with knowledge of your implementation can still get to it. Everything is public. Okay, but at least it's a suggestion. It should be a private. You get one constructor, so you don't get constructor overloading in Python. The constructor is named underscore underscore init underscore underscore. You can pass it as many arguments as you want, but you only get one. Okay, so I might say size, value. Whoops, didn't like that. Why not? Because I didn't say def. And that class tag, great. Def, init, size, value. Then what's wrong with this? I've already made a mistake. I need self. So easy to forget self. So self.size equals size. Just not my day. I'm missing strokes. So just remember, use the self in order to initialize your instance variables. Okay, and something that always gets people with is they think, oh, you can just, why bother with self? Why not just define something like here, tricks equals a list, and then I'll add a function, add trick, and I will be appending the trick that my dog does to tricks. So I set smiley equals dog and ever equals dog. And I add smiley can beg and ever can fetch. And when I print smiley's tricks, amazingly, smiley can now fetch. And ever is capable of begging because this is a shared class variable. And when I go to change it, it actually just changes the shared list. Quite annoying. So just much better if you instead declare tricks in the constructor.
So if tricks doesn't have self in front of it, it is a list that all instances of dog have access to?
No. If I had not put self here, then it would have actually given me an error message because tricks would be undefined. Remember.
Oh, I see. So this syntax is acceptable where it's class dogs and tricks is not declared as self above the constructor?
Right. Yeah, so this is outside the constructor. This is just in effect declaring a class variable. So it's declaring a property of dog. So you don't have to say self there. But now down here in add trick, I do have to call self in order to access that variable. Is that answering the question, or is there something I'm missing?
No, that answers my question.
Yeah, you just got to be very careful. Anything, any property defined outside of a method is effectively a class variable. Okay. So we defined constructor, we defined instantiation. So to create a instance of a class, you just give the class name and any arguments. Remember, there's only one constructor. So this is the way I would invoke it if the constructor took no arguments. This is how I would invoke it if the constructor took 2 arguments. If you just want a C-style struct, the way you typically do it is define an empty class body using pass. And then when you create an instance of the object, you can just dynamically add properties to it. And if you just want a simple object without having to create a class, so you use a dictionary. So if you just want a bunch of key value pairs without having to go through a whole thing of creating a class, you could create something like student equals name, Brad, GPA 3.8. Thought I could get away with that, but I can't. So that's a way of creating an unnamed object. You use a dictionary. Hey, if you want inheritance, then it is the derived class name and the base class is in parentheses. So here, Labrador Retriever is a subclass of dog. All methods are virtual, so it's easy enough to override your superclass methods. And if you want to call the superclass method, it's like you do it in C++. You give the base class name and the method name. And the reason you do that is that Python supports multiple inheritance, which we won't get into and I won't hold you responsible for, but because it does multiple inheritance, super, which is what Python uses to access the superclass, could be ambiguous if you have multiple parents. So you have to explicitly provide the base class name. Questions? Okay, so got about 15 minutes, and what I want you to do in those 15 minutes is I have a short actually, I think I may not have time to have y'all do it. So I think what I'm going to do is go over it rather than have you do it. So I will have you look at, so I am going to do this for you because I realize in 15 minutes there's not enough time for you to do it. So take a look at this, what I'm going to do. Okay, so what I'm doing, I'm creating a doubly linked list with a Sentinel node. Okay, so it's basically, here's my Sentinel node. That, and like that. And in order to do comparisons, so I said find, unless the less than operator has been overloaded, you couldn't compare two objects. So the way I'm handling that is to force the constructor to take a comparison function so it can compare two values in order to allow the find to be done. Then I want to provide a way to allow someone to iterate through my list as though it were a sequence. So for that, I need to create this iter method, and this is a predefined method that Python recognizes. And when you try to type something like for I in X, it uses, what it really does is it goes to X and it calls this iter method. So that should be a generator function that returns the next node in the list. Okay. So I said name the file dlist.py, put the file in a package named list. So let's look at my solution. So here's my directory. It's named list. Here's my init.py because it's part of a package. Here's my dlist.py. You'll notice both of them have been imported, hence they also have compiled versions. So I first define a node for my list that takes a value and stores it. And next, by the way, in Python, none is the null value, capital N. So I'm making my next and previous point to nothing. So then my class dlist, the constructor, needs to create a Sentinel node. So self.sentinel, it creates a Sentinel node that has a node with no value. And as you can see, it simply sets the next and previous pointers to itself. And we also store the comparison function that was passed in. Okay, so that's in the init. Then append. Turns out that append appends to the end of the list, but you can use insert before. That's the whole point of using a sentinel. So if you insert before the sentinel node, that is the same as appending to your end of your list. So then insert before, I want to insert this value. Oops. I want to insert that value before this node. So I create a new node using this syntax I call dnode. Then I set, it should be pretty clear what's going on, but in case it's not, when you insert so we have a pointer to node. It's pointing back via a previous pointer here. So I'm going to create another temporary pointer called previous node to make it easy to do the insertion. So I'm inserting a node right there. So it should be pretty clear we need to make previous nodes next point to our new node. Our new node's previous needs to come back and point to previous node. Node's previous is going to point to our new node. And our new node's next is going to point to node. So we first do what I said. We create a temporary variable with previous node. Then new node's next to node. New node's previous to previous node. Previous node's next points to new node, and node's previous to new node. So it's just linking it in. And notice there's no use of self here, because I was all basing it off of this node that was passed in. So there was no issue. When I'm done, new node and previous node will disappear, but that's okay. Okay, erase. You should know how to do erase, so I'm not going to spend time on that. Should be pretty simple. Okay, find. So I want to determine if any node in this list contains this value. So for node in self. So notice I'm iterating through my D list, but not using the next pointer. Instead, I'm using a for loop, and I call my compare function by passing it the node's value and the value I'm comparing. If it returns true, I return the node. Now notice the use of the else statement with this for loop. So if the for loop terminates, I did not locate the value, because if it did locate the value, I returned from the function. So if the for loop terminates, I get to this else clause and I know that the value did not exist in the list. Therefore, I return none. So acute use of else here. But the other thing, yes?
You're probably going to cover it. I don't understand the for in self.
Okay, we're going to it right here. So that's the next thing, is that how in the world did I get away with not having to use the next pointer? So that is where this iter function comes in. So what it is doing is a generator function, and it's going to generate each node in the sequence or in this list one at a time. So it takes as a argument, the pointer to the list, and it sets current node equal to the first node in the list, which is sentinel.next. And now, while current node not equals self.sentinel, because remember that's how we detect the end of a list, is when we get to the sentinel node, yield the current node. So that's the key here. So yield is like a print statement or a return statement. It's returning this node. And yield stops the function right there, but it retains its current state. So what happens up here, it says for node in self. So what happens, this in, or this for, calls this iter, which remember is a predefined method in Python. It has special meaning. It's a reserved function. I shouldn't say predefined. It's a reserved function name. So for will always call this function in this object. So it starts executing and it makes current node point to the first node in the list. Then if the current node is not the sentinel node, it yields the current node. So that returns current node and stores it in node. Okay, we execute the function and let's say it fails. The function calls fails to compare. So we ask for the next node. So now it again calls iter, but it picks up right after the yield statement. So it now makes current node point to the next node, checks to see if we've reached the end of the list, and if not, it yields the next node. So that's what's going on, is that this iter function is hiding the way that we traverse the list using these next pointers. So think of this like operator overloading in C++. It's like it's overloading the in, so that instead of having to explicitly write a loop that manipulates the next pointers, instead in is simply calling this iter function, and the iter function is successively generating nodes in the list. Does that make sense or not? I'm not going to claim this is simple to see.
No, this is very cool. This makes perfect sense to me.
Okay, good. So that is what is going on. So that's why dictionaries, lists, sets, you can all iterate through them in Python because they all have a predefined iter method. And then you can define your own iter method for your own class. And using it, you can iterate through it using a for statement. So pretty neat. So the point of this exercise was severalfold. First of all, I wanted to show you that indeed, just like in Java, you can create linked data structures in Python. Point two, unlike Java, you have function pointers in Python. So you can simply call a passed-in function, just like you could in C or C++. Now, there is operator overloading, so I could also have overloaded the equal operator for this value. That would also work, but we're not doing operator overloading in this course. And the third thing I wanted to show you was how you could turn any class into an iterable sequence using this iter method, which is a generator function. So that was the three primary points behind showing you this dlist class. And then I guess the fourth one was in keeping with the general spirit of today. The way I created the package was by putting it in a directory named list. There is a init.py. You can see I initialize the all variable to be dlist. And then up here, there was a dlist driver. And it imported the dlist. So from list import star, and because I had set up that all variable, it imported the dlist package. What am I doing there is an interesting, what I'm doing here is calling the constructor and passing in a comparator function. And in this case, the comparator function, it just returned the result of comparing A and B. So it assumed that the comparator function would work because I was just appending strings. Okay. And you can see, rather than after I did my appends to print the items in the doubly linked list, I just said for n in X, print n dot value. So I didn't have to bother with using the next function. You'll also notice value was public. I didn't go through any accessor function. Okay, so that takes care of Python. You should be able to finish the homework assignment at this point. You still have a few days to finish it. And this finishes our brief and rather rapid introduction to scripting languages. Next time, starting Thursday for 2 weeks, we will be talking about concurrency. So we will be delving into threads and locks and all that good stuff that goes along with having things execute concurrently. So for those of you in 360, this should be interesting for you because you'll kind of be able to compare and contrast Java's threads library with the C POSIX threads library. I think you'll find that it's easier to do stuff in Java than in C, but you can draw your own conclusions. So with that, I will let you all go. I will see you on Thursday.